Could our universe be just one chapter in an endless cosmic saga? The James Webb Space Telescope is turning everything we thought we knew about the cosmos upside down, revealing galaxies so strange and massive that they challenge the very foundations of modern astronomy. These discoveries don't just refine our understanding, they force us to question whether the familiar Big Bang narrative tells the whole story. Among the most daring ideas comes from Nobel laureate Sir Roger Penrose, who suggests the universe moves in infinite cycles of death and renewal, and that remnants of a previous cosmos might still linger in our skies. Today, we'll dive into the astonishing findings Webb has uncovered, exploring galaxies that defy time itself, radiation that shouldn't exist yet does, and the tantalizing possibility that the universe we see is only part of a much larger, mysterious cosmic puzzle. When Webb turned its powerful eye toward the Big Dipper, it detected faint, enigmatic lights traveling across space for over 13 billion years. These signals came from objects born just 500 million years after the Big Bang, yet they were already enormous, rivaling the size of the Milky Way. According to current models, there simply wasn't enough ordinary matter in the early universe to form such massive structures so quickly. And yet here they were, so strange and powerful that astronomers have nicknamed them universe breakers. These early giants didn't just push the boundaries of what we thought was possible, they shattered them, forcing scientists to reconsider everything from galactic formation to the fundamental timeline of the cosmos. The discovery didn't stop there. Webb soon revealed more galaxies, each teeming with stars far too rich for their youth, hinting that the early universe was far more complex and astonishing than anyone had imagined. Webb's discoveries didn't just challenge our ideas about galaxy formation, they also shook the foundations of cosmic expansion itself. For decades, scientists have relied on the Hubble constant to measure how fast the universe is stretching, expecting a rate of 67 kilometers per megaparsec. But observations using supernovae, red giants, gravitational lenses, and pulsating stars consistently pushed that number higher to 73 kilometers per megaparsec, a discrepancy that has long puzzled cosmologists. Now Webb's data confirms and even deepens this cosmic mismatch, raising an unsettling question: why doesn't theory match reality? Some researchers are exploring a radical answer: our universe may be colliding and merging with other universes. What if the rapid inflation after the Big Bang wasn't a random burst of growth, but the result of our newborn cosmos interacting with a larger parent universe? Mathematical models simulating these interactions suggest that what we perceive as expansion could actually be the stretching and merging of cosmic domains, hinting that our observable universe is just one fragment of a vast, interconnected multiverse. Surprisingly, when scientists applied this model, the predicted expansion matched observations far better than the standard model ever did, turning what seemed like speculative theory into a potentially vital piece of the cosmic puzzle. To truly grasp the implications of Webb's findings, we need to journey back to the universe's earliest era, when it was shrouded in darkness. Before the first stars ignited, dense clouds of neutral hydrogen filled space, creating a cosmic fog that absorbed and scattered ultraviolet light, leaving the cosmos pitch black. Then, as the first stars formed, they began emitting powerful radiation that ionized the surrounding gas, gradually clearing the fog and illuminating the universe in a process known as reionization. Models have long suggested this transformation began around 300 million years after the Big Bang, with early galaxies creating small glowing bubbles where light could escape. Yet Webb's observations have completely upended that timeline. One galaxy, known as Jade's GSZ 11, shines brilliantly just 33 million years after the Big Bang, emitting far more ultraviolet radiation than scientists expected. Analysis revealed the unmistakable signature of Lyman alpha radiation, a marker of energized hydrogen, which shouldn't have been able to escape the surrounding neutral gas at such an early stage. This discovery implies that cosmic reionization may have begun earlier or progressed faster than previously thought, forcing astronomers to reconsider the role both massive and smaller galaxies played in lighting up the young universe. The questions only deepen. What powered this galaxy's intense UV radiation? Could it be a cluster of super-hot stars or an active black hole at its core? Whatever the explanation, the universe is clearly defying the rules we believed governed its infancy. If the early universe was already defying expectations, the implications stretch even further. What if the Big Bang itself wasn't the absolute beginning, but rather a transitional event, a bridge from a prior universe to our own? This is the bold idea championed by Sir Roger Penrose, a Nobel Prize-winning physicist, who proposes that the universe operates in infinite cycles of death and renewal. In his view, what we call the Big Bang was not the birth of everything but a big bounce, a moment when one cosmic era gave way to the next. According to Penrose, the universe continues expanding until all matter eventually decays into pure energy, a timeless, spaceless state, after which a new universe emerges, restarting the cycle. Even more astonishing, he believes he has already found evidence of these previous cosmic eras, hidden in the faint remnants of the cosmic microwave background. Circular patterns, or Hawking points, appear in this ancient radiation, potentially marking the energy released by evaporated supermassive black holes from a universe that existed before ours. These spots, roughly the size of the full moon, could be the first tangible signs that the cosmos is far older and far more cyclical than we've ever imagined. While skepticism remains high in the scientific community, Penrose draws a parallel to black holes themselves, once theoretical curiosities dismissed by many, now undeniable realities, suggesting that the same could one day be true for Hawking points and the evidence of prior universes. The discoveries from the James Webb Space Telescope don't stop at theoretical implications. They're rewriting our understanding of how galaxies formed and evolved in the earliest epochs of the universe. Galaxies like Jade's GSZ11, shining brightly just 33 million years after the Big Bang, challenge everything astronomers expected about cosmic evolution. These galaxies aren't small, chaotic clusters. They're massive, structured, and already producing intense ultraviolet radiation, carving enormous bubbles of ionized gas that should have taken far longer to form. Their Lyman alpha emissions, which signal energized hydrogen, are escaping earlier than models predicted, suggesting that reionization, the process that cleared the cosmic fog, may have begun earlier or progressed faster than previously thought. This raises an even more intriguing question. What powered such extraordinary radiation at this stage? Could it be an unusual population of extremely hot, luminous stars, or perhaps active black holes at their cores? Either way, these findings force scientists to reconsider the timeline and mechanisms of early cosmic evolution. They hint that smaller, less massive galaxies may have played a more significant role in illuminating the universe than we ever imagined, adding another layer of mystery to the unfolding story of our cosmos. These revelations naturally lead to one of the most provocative questions in modern cosmology. What if the Big Bang wasn't the absolute beginning? Sir Roger Penrose, the British Nobel Prize-winning physicist, proposes a bold idea that the universe isn't a one-off event, but part of an eternal cycle of death and rebirth. In his view, the Big Bang was not the start of everything, but a big bounce, a transition from a previous universe to our own. According to Penrose, the universe continues expanding until all matter decays into pure energy, reaching a state of timeless, massless light, and eventually contracting into the seeds of a new cosmos. What makes this theory even more thrilling is that Penrose believes he has already found evidence of previous universes hidden in plain sight within the cosmic microwave background, the faint radiation left over from about 380,000 years after the Big Bang. He and his team have identified mysterious circular patterns called Hawking points, which could be the residual energy from evaporated supermassive black holes in a prior cosmic era, quietly etched into the fabric of our current universe. If confirmed, these imprints would suggest that the universe has been cycling through phases of destruction and renewal far longer than we've ever imagined, opening up a mind-bending perspective on cosmic history and the very nature of reality itself. The discoveries from the James Webb Space Telescope are forcing us to rethink everything we thought we knew about the universe, from the rapid formation of massive galaxies to the very origins of cosmic history. Each new observation challenges the boundaries of modern cosmology and hints at forces, processes, or even previous universes that remain hidden from our current understanding. Sir Roger Penrose's theory of cyclical universes and the tantalizing evidence of Hawking points offer a glimpse into a cosmos far more complex and mysterious than the linear Big Bang model suggests. Whether these findings confirm a universe in eternal rhythm or simply point to gaps in our knowledge, one thing is clear: the universe is not playing by the rules we imagined, and every new discovery is a step closer to unraveling its deepest secrets. As we continue exploring, we're reminded that the story of the cosmos is far from complete, and the next revelation could completely rewrite our understanding of existence itself.